Hello, my name is Abby Dixon, and I am the co-captain of FRC Robotics Competition Team 5459 Ipswich Tigers. I also participate in CAD design, fabrication, and assembly of mechanical components of the robot. Today, I would like to share with you what I believe to be the most fascinating design innovation on our team's 2023 season robot, our chain-driven, telescoping, pivoting arm. For the 2023 season, Charged Up, our team set our sights high with aims to score both cubes and cones on the highest nodes. However, to maintain agility while driving and stability while balancing on the tippy charge station, we also decided to prioritize compactness and a low center of gravity. This is what ultimately led us to the decision to utilize a telescoping arm system with which we didn't have to compromise extension length to achieve compact storage.
Our team uses the Onshape CAD software because of its functionality as a collaborative, cloud-based workspace. This allows our CAD team of about 3 students to work together on the CAD model simultaneously, which is essential to help check each other's dimensions and placements of major and minor components alike. To maximize extension distance and compactness, we decided to make a 2-stage arm out of aluminum square box tubes in 4-inch, 2.5-inch, and 1-inch sizes. The extension is driven by one Falcon 500 motor on a 5:1 max planetary gearbox. The system contains 4 loops of number 25 roller chain, 2 that drive the lifting and lowering of the stages, 1 that powers the lifting of the innermost stage without the need for an additional motor, and 1 short loop to connect the motor and the gearbox to the first lifting and lowering chain loop. The secret to this cascade of extension is the careful placement of anchor points that fasten the roller chain to the stages, as explained by this diagram. The anchoring of the chain that runs along the outside of the first stage to the top of the outer housing is what enables all 3 extension chains to be powered by one single motor. To help the stages stay aligned while extending and retracting, we designed 3D printed blocks that hold bushings that freely rotate tangent to the sides of the tubes. To assemble the arm, we first printed out a template of the lightning holes from CAD and traced it onto the tubes before cutting them out with a jigsaw and a handheld router. Next, we 3D printed and assembled the bushing blocks to mount onto the top of the tubes later. For the chain anchor, we cut nylon blocks, fastened them to the bottom of each tube, and drilled and tapped a hole to screw into, holding the chain anchor in place. The nylon blocks also double as slider blocks that help keep each stage aligned inside their outer housing. Finally, we cut 1/2-inch aluminum hex shaft to length to hold the sprockets and retain them with shaft end screws. The most difficult part of the assembly process was adding the chain. We first attached each chain to its anchor point. Then, working from the innermost stage outward, we looped the chain onto the sprockets. Once everything was properly packaged, we screwed on the bushing blocks and mounted the end effector. Since the end effector is driven by a Neo 550 motor, we had to run 3 power wires and a data cable through the full length of the arm to power the motor. In order to keep these wires from becoming caught or tangled when the arm extends and retracts, we fabricated a polycarbonate track for a loop of energy chain to slide on. The energy chain loops around a shaft and pulley, and constant force springs pull the shaft back to the top of the track when they are not being pulled against by the extension of the arm. To test the arm and practice our scoring cycles, we took a trip to WPI's practice field. As planned, our finished product reached the mid and high node levels.
In order to make the creation of this telescoping arm possible, it first had to pass through every single pair of hands on our team. Early in the season, our strategists and CAD designers worked to decide on the most feasible and efficient design before joining the mechanical department in order to fabricate and assemble the tubes, chains, bushing blocks, anchors, and shafts. Particularly during the assembly process, my fellow mechanical department members and I learned to improve our communication with each other to make the process run more smoothly. Then, our electricians and mechanical department members collaborated to design and assemble the cable management system to then hand it off to the software department to pre-program the extension positions. Finally, as the operator on Drive Team, I collaborated with our drive coach, driver, and human player to develop the most efficient scoring cycles during matches. Thank you for watching, and I hope you enjoyed learning about the design innovations on our 2023 season robot as much as I enjoyed sharing them with you.